In my last videos, we learned different strategies on how to factor different types of polynomials. And now we're going to use this method of factoring in solving for quadratic equations. In the previous video tutorials, we learned different strategies in factoring polynomials. Now, we're going to use those strategies in solving for the roots of a quadratic equation. Let's take a look at example number 1. We have x squared minus 2x minus 35 is equal to 0. So this trinomial can be factored out using product of negative 35 and a sum of negative 2. And that gives us using the numbers negative 7 and positive 5. Because negative 7 and positive 5 will give you a product of negative 35, and when you add them, it's negative 2. So the complete factors of that quadratic equation is x minus 7 times x plus 5 is equal to 0. So using the zero product property, we now have x minus 7 is equal to 0 and x plus 5 is equal to 0. Because this means if we're multiplying two numbers, one of them or both of them should be 0 to get a product of equal to 0. So using that concept, we now have x minus 7 equals 0, which means solving for x, we add 7 to both sides. So one value of x that will make this equation 0 is x is equal to 7. The second value of x, we subtract 5 to both sides. That means we have x is equal to negative 5. Now let us check whether 7 and negative 5 will really make the equation true. 7 squared is 49. 49 minus 14 is 35. Take away 35 is 0. So indeed, 7 is a solution to this quadratic equation. If we substitute negative 5 squared is 25. This becomes positive 10, so 25 plus 10 is 35. Take away 35, that's also equal to 0. So the roots of this quadratic equation are 7 and negative 5. Try to recall special cases of factoring. We have 4x squared minus 12x plus 9 is equal to 0. In this trinomial, the first term is a perfect square because we can multiply 2x by itself to get 4x squared. 9 is also a perfect square because we can multiply 3 by itself to get a 9. And when you multiply 2x and 3, that's 6x, doubling it will give you negative 12x. This means this trinomial is a perfect square trinomial or PST. So we can factor this as 2x minus 3 to the second power. And we have equals 0. Or the same thing as 2x minus 3 times 2x minus 3 is equal to 0. So in this problem, we will only have one root for the quadratic equation, and that is 2x minus 3 equals 0. Add 3 to both sides. We have 2x is equal to 3. Divide both sides by 2. That means x is equal to 1.5. Again, you could also check by plugging in 1.5 back into the equation, and that should be equal to 0. Our example number 3 is 9x squared minus 25 is equal to 0. Also, this is a special case. 9x squared minus 25 is a difference of perfect squares. Perfect square minus a perfect square. So this can be factored out as 3x, that will give us 9x squared. Negative 25, we can do positive 5 and negative 5 is equal to 0. And again, if you do distributive property, you should get 9x squared minus 25 is equal to 0. Since we have two factors, that means we can get two values of x. The first is 3x plus 5 is equal to 0, and the other, 3x minus 5 is equal to 0. Solving for each value of x, we subtract 5, then we have 3x is equal to negative 5. Divide both sides by 3, that will give us x is equal to negative 5/3. For the second problem, 3x minus 5 equals 0. We add 5 to both sides. That's 3x is equal to 5. Divide by 3. So the x value is 5/3. So the values for x that will make this true would be plus or minus 5/3. Now let's have example number 4. We have 3x squared plus 9x minus 54 is equal to 0. So in this quadratic equation, 3x squared plus 9x minus 54 equals 0, there is a GCF, and the GCF is 3. So when we factor out 3, that becomes x squared plus 3x minus 18 is equal to 0. So when you do distributive property, that's 3x squared, 9x minus 54, and then we have 0. Now, these parentheses can be factored out by using product of negative 18 and a sum of 3, which means we're using positive 6 and negative 3. Positive 6 times negative 3 is negative 18 when you multiply them, and when you add them, it's positive 3. So we have x plus 6, x minus 3 is equal to 0. Again, using the zero product property, we have x minus 3 is equal to 0. We have x plus 6 is equal to 0. And of course, 3 is not equal to 0. So if one of these parentheses, or both of these parentheses are equal to 0, then the whole thing becomes a 0. This means that the x values are negative 6 and positive 3. So these are the roots of that quadratic equation. Now let's have example number 5. We have 2x squared plus 5x minus 12 is equal to 0. So for this trinomial, 2x squared plus 5x minus 12, we can easily factor out 2x squared because it's a prime number. We can only use 2x and 1x to get 2x squared. However, on the minus 12, we need either 1 and 12, 2 and 6, 3 and 4, and of course one of them is negative, the other one is positive. We need a middle term of positive 5, so I will be using plus 4, because if I will multiply 2x times 4, that will give me 8x, and I will be using here negative 3, because if I will multiply negative 3 times x, that's a negative 3x. And when I add the 2, that gives me positive 5x is equal to 0. And if you can factor it using mental math, then you can also use the diamond method or factoring by grouping. So now that we have these factors, 2x minus 3, x plus 4 equals 0, now we're ready to find the roots. We have 2x minus 3 is equal to 0, and then we have x plus 4 is equal to 0. So what are the values of x? We have x is equal to negative 4, because that means you subtract 4 to both sides, and the other one is 3 over 2, or that is 1.5, because we need to add 3 to both sides, and then divide by 2. So we have 3 over 2, or 1.5, and the other one is negative 4. For example number 6, we have x squared plus 4x minus 7 is equal to 0. So this means we need to get two numbers that multiplies to negative 7 and adds up to 4. But here's the problem. The only factors of negative 7 are either 1 and negative 7, or negative 1 and positive 7. And none of this will give you a positive 4 when you add them. So this means this quadratic equation is not factorable. Since the quadratic equation is not factorable, this means that we cannot find the roots of this quadratic equation using this method. But there are two other ways on how to solve for the roots of a quadratic equation. Another one is by using quadratic formula, and the second is by completing the square. So please watch for my upcoming videos on quadratic formula and completing the square. Thank you.